Today we're going to get some more practice with finding derivatives using the chain rule. And we're going to start out with this particular problem. You might want to just write it down and try to do it on your own. Let me focus it a little bit better here. So y equals x plus the square root of x all raised to the -2 power. So you should shut the video off and try this on your own and see what you get, what I get. See if you get what I get. So using the chain rule, you're going to bring the -2 down front and keep that x plus the square root of x exactly the same, and then subtract 1 and you get times to the -3rd power. That's without the chain rule, but then using the chain rule, you have to multiply that by the derivative of the inside. The derivative of the inside is 1. The derivative of x is 1, and the derivative of the square root of x, which is x to the 1/2 power, I think we've done this quite a bit, is 1/2 times x to the -1/2, which is 1/2 square root of x. All right, so that's the chain rule. And the only thing we might want to do is clean this up a little bit. If we pull this x plus the square root of x to the -3 down into a denominator of a fraction, we're going to end up having a complex fraction here that we should simplify. So what I'm going to do is I'm going to simplify this by just combining these terms. And if you combine these terms, you're going to call 1 with the like denominator. You're going to call this 2 square root of x over 2 square root of x. So then when you add these two together, you get 2 square root of x plus 1 all over 2 square root of x. So let's just write that out. X plus the square root of x to the 3rd times 2 square root of x plus 1 all over the common denominator. And then the next thing we can do is we can pull this, to the -3rd, we can pull this down to the bottom and attach it to this. So we've got y equals -2 stays in the numerator. This goes to the denominator. This stays in the numerator. So we have 2 square root of x plus 1. And in the denominator we have, well, I think I'm going to start out with 2 square root of x and then attach it to the rest of it. So we have 2 square root of x from here. And then we have x plus the square root of x raised up to the +3rd power when we bring it down. And the only other thing that we can do with this is the 2's will cancel out because they're common factors. So what we're left with is -2 times, negative parentheses 2 square root of x plus 1, or if you wanted to distribute the negative, you could. You don't have to, over the square root of x times x plus the square root of x raised to the 3rd power. And this cannot be distributed in because this has an exponent. So that would be your final answer for number 1. Number 2, let's try y is equal to 1 over the sine 5th, not sine squared, but sine 5th of x minus cosine cubed of x. Let's find y prime. So shut the video off. I'll zoom in a little bit. Right, what I would do would be, I would call this sine of x raised to the -5th power to move it up to the numerator, minus parentheses cosine of x to the 3rd power. That's what cosine cubed means, is cosine raised to the 3rd power. So we have an outer function, which is x to the -5th, and an x to the 3rd, and then the inner functions. So if we wanted to find y prime, we bring the -5 down front, times the sine of x to the -6, sorry. -5 minus 1 is -6. And then multiply by the derivative of the inside, which is the cosine of x. So there's your derivative of the first term. The derivative of the second term minus, now you drop the 3 down front, and 3 cosine of x squared, and then the derivative of the cosine is the negative sine of x. And the only thing we'll do here is clean this up a little bit. There's really nothing to do here except if you want to move the sine of x to the -6 down to a denominator. and keep the -5 and the cosine of x on the top. So in the bottom it would be sine 6 of x. And then we have a minus and negative, so that becomes a positive, and nothing is in the denominator here, so we just have 3 cosine squared of x times the sine of x. And you can put parentheses around those x's if you want to. So that would be it for number 2. The next example, number 3, let's do y equals sine cubed of x times the tangent of 4x. So shut the video off, try this one on your own. What I would do here is I would call this, instead of the sine cubed of x, I would just rewrite this as the sine of x raised to the 3rd power. So when I do the chain rule, I've got the outer and the inner function. So we have a product rule here, first times the derivative of the second plus second times the derivative of the first. So y prime is equal to the first term is a sine of x to the 3rd power. The derivative of the tangent is the secant squared of 4x, and then the chain rule says you have to multiply that times 4, the derivative of the inner. So there's your derivative of tangent of 4x, it's secant squared of 4x times 4. So that's first times the derivative of the second plus, now we have second times the derivative of the first. So the second is tangent of 4x, and the derivative of the first factor is 3 times sine of x to the 2nd power. Let's see, to the 2nd power times the derivative of the sine of x, which is a cosine of x. And that's about it for that one, except I think we can just clean this up a little bit. Usually you'll have a 4. If you have a coefficient, you'll move that out to the front. So I'll take this 4 off the back of it and put it out in front. So you have 4 sine cubed of x. I'll take that 3 off from here and just call it 4 sine cubed of x, secant squared of 4x. And then the only thing that we have here is we have a 3 coefficient that we usually move in the front. So we have 3 tangent of 4x times a sine, usually you call that sine squared of x, so I'll take that off from here, times the cosine of x. And that's it for that problem. If you wanted to rewrite that again a little more neatly, you could. And we'll do 2 more problems, I promise. Let's have an r and a theta this time. Let's say r is equal to the square root of theta times the sine of theta. And the instruction is to find dr d theta, which is the same thing as just r prime. Or if you like x's and y's, you can replace this r with a y and these thetas with x's if you don't like these Greek letters. But that's how it might be given to you, and you're going to be asked to find dr d theta. Well, what I would do is I would rewrite that square root as the 1/2 power. So r is equal to theta times the sine of theta, all raised to the 1/2 power. And the derivative, we've got a chain rule going here, but you bring the 1/2 down, and then you change that to a negative 1/2. So let's just plop this 1/2 down in front and call it r prime. And then 1/2 minus 1 is negative 1/2. So there's the first part of it. And then the chain rule says we have to multiply it by the derivative of the inside. Well, the derivative of theta sine of theta, we have a product rule here. And the product rule says we have to multiply the first times the derivative of the second. So the first is theta, and the derivative of sine is cosine. So first times the derivative of the second plus second times the derivative of the first. So the second term is sine theta. The derivative of theta is just 1. So that's it for the chain rule. There's your derivative here. Now the next thing we're going to do is we're going to bring the negative exponent down to the denominator, and we're going to call that the square root. So this 2 is in the denominator. This will be the square root in the denominator, and this whole term will be up in the numerator. So we'll have theta cosine theta plus sine of theta up in the numerator, and the denominator will have a 2, and then it'll have a square root of theta sine of theta. And there's really nothing else we can do. There's nothing to cancel out or simplify. So that would be the final answer for r prime, which is the same thing as dr d theta. And then we have one more problem to do. And this last problem is a doozy. So you should take these previous 4 problems were pretty straightforward, but this problem number 5 will take you a little bit longer because there are some nested chain rules that are going on here. So spend a little bit of time on this one. Y is equal to parentheses 1 plus cosine squared of 7x all raised to the 3rd power. All right, so take that one, find the derivative of that, find y prime, and you've got a power rule and you've got some chain rules, multiple chain rules going on, and let's see how you do on that one. You should turn the video off and try this on your own. So what we're going to use now is the chain rule when the outer function is x cubed and the inner function is this whole part of what's inside parentheses. So the derivative is you drop the 3 down in front and you don't change that, so it's 1 plus cosine squared of 7x, don't change it, and you bring it to the positive 2 power. And then the chain rule says now we have to multiply this by the derivative of the inside. Well, what's the derivative of the inside? The derivative of 1 is 0. So we don't even have to put that 0 plus. Now what we have to do is find the derivative of the cosine squared of 7x. Well, the cosine squared of 7x is the same thing as the cosine of 7x to the 2nd power. And so we've got an outer function of x squared and an inner function of cosine of 7x. So the derivative of that would be 2 times the cosine of 7x to the 1st power times the derivative of the cosine of 7x. The derivative of the cosine of 7x is negative sine of 7x, and the chain rule says multiply that by 7. So really that's pretty much it. And then what we have to do is clean things up a little bit, see what we can combine and what we can't combine. Well, one thing that we can't combine is this 1 plus cosine squared. I'm going to move this 2 right back down to the cosine squared here because I'm not going to take any more derivatives. So we have a 3 times this whole binomial times this, which is a monomial because this is just 2 times cosine 7x times negative sine 7x times 7. So we can multiply these factors together. 3 times 2 is 6, times negative 1 is negative 6, times 7 is negative 42. So y prime is equal to negative 42. That took care of the 3 and the 2 and the 7. And the negative. And then what do we have next? We have the cosine of 7x. We have the sine of 7x. And then last of all, I'm going to put this binomial down, which is 1 plus the cosine squared of 7x. And it looks like that's about all we could do. We could actually distribute this term into these 2 terms inside here, but I don't think that's necessary. Usually we try to factor out a common factor. So that would be the end. And if you got this answer, then you're good. And that's the end.